converts this knowledge into a data science problem definition. The second is data understanding. The data understanding phase starts with an initial data collection, and it proceeds with activities in order to get familiar with the data, to identify data quality problems, to discover first insights into the data, or to detect interesting subsets to form hypotheses for hidden information. The third comes the data preparation. The data preparation phase covers all activities to construct the final data set, data that will be fed into the modeling tool from the initial raw data. And then comes the most interesting, modeling. In this phase, various modeling techniques are selected and applied, and their parameters are calibrated to optimal values. Typically, there are several techniques for the same data mining problem type. Some techniques have specific requirements on the form of data. Therefore, stepping back to the data preparation phase is often needed, right? And then you see a to and fro from here between data preparation and modeling. The next phase is evaluation. At this stage in the project, you have built a model that appears to have high quality from a data analysis perspective. Before proceeding to final deployment of the model, it is important to more thoroughly evaluate the model and review the steps executed to construct the model to be certain it properly achieves the business objectives, right? So you refer back to the business understanding. And a key objective is to determine if there is some important business issue that has not been sufficiently considered. So at the end of this phase of evaluation, a decision on the use of the data mining results should be reached. The last one is deployment. Creation of the model is generally not the end of the project. Even if the purpose of the model is to increase knowledge of the data, the knowledge gained will need to be organized and presented in a way that is useful to the stakeholder or to the customer. Now, depending on the requirements, the deployment phase can be as simple as generating a report or as complex as implementing a repeatable data scoring process and could be in production, right? And as you see this process, I like you to think and, if possible, even write down about all the tools and collaboration required to complete this cycle. What tools are used by a business analyst with an understanding of the domain and objectives? Or what tools are used to initially explore the data for better understanding? Where do your data sources intersect during the data preparation stage? What tools do you use when building a pipeline, a machine learning pipeline, and training your model? How and where is your model evaluated? And at the final point, when you believe the model is ready for production, how and where is it deployed and how will it be consumed? These are some questions that we really need to think about that goes beyond the modeling part. And hence we will get this full picture of a complete data science life cycle. Now on the right, I've also listed some of the personas that we have from data engineering, data steward, data scientist, business analyst, and application developer. These are some unique terms that we give to understand, and these could be different across the industry. The naming could be different, but usually a data engineer's role is to architect data pipelines and ensure the operability. There are different roles. The second is data steward. Data steward is responsible for the governance of the data and ensures that the regulatory compliances are abided by. So if you worked on different projects, you might have come across GDPR, HIPAA, CCPA. There are different regulatory compliances depending on the domain of the use case. The third is data scientist. Data scientist role, of course, we are deep into it. It gets deep into the data to draw insights for the business. The fourth is business analyst. He or she would be responsible to generate the visual insights, right? Works with the data to apply insights to the business strategy. And the fifth persona is of an application developer who's responsible to plug into analysis and code to building the applications further. Now, what you see are the different stages of AI journey, and your ability to follow the data science life cycle correlates with your success in getting value from your projects. First, I like to break the data science life cycle into three subcycles: the build phase, the deploy phase, and the infuse phase. To support the needs of people that do data exploration, data preparation, and modeling, you will need to have visual and open source coding based tools that help you accelerate the time to complete and iterate during the build phase. Once a model is built and trained, it needs to be deployed, auto retrained, and managed. After that, you can use a service to perform model monitoring and operation. And you can audit payload by logging. This helps the explainability part, transparency, and usability for production. Automated machine learning, AutoML, is the process of automating the manual task that data scientists must complete as they build and train machine learning models. Now, these tasks include feature engineering and selection, choosing the type of machine learning algorithm, building an analytical model based on the algorithm, hyperparameter optimization, also known as HPO, training the model on tested data sets, and running the model to generate scores and findings. Now, researchers developed AutoML to help data scientists build predictive models without having deep ML model expertise. Let's see how Auto AI does all of this. There are a lot of tools that can help do this. It will automatically ingest, clean, transform, and model with hyperparameter optimization. There are also training feedback visualizations that provide real time results to see model performance. And last, there is also one click deployment possible. AutoML frees data scientists from the raw task involved in building a machine learning pipeline, allowing them to focus on extracting the insights needed to solve important business problems. So, why these automated AI methods? Let's see from an analytics manager view. The first reason would be that there is a lot of diversity in skill levels and so many different open source frameworks. Today, there are a lot of citizen data scientists emerging. Nearly 50% of data scientist respondents on Kaggle said that they had less than 2 years of experience on machine learning methods. The second side of it is operationalizing AI itself becomes hard. Now, data scientists have difficulties with integration into engineering and support efforts. The models need to be retrained automatically to maintain accuracy. The machine learning pipelines need to be deployed and managed, not just the models, right? So this is the view that we have from managers, and hence, these automated machine learning methods are definitely becoming important. And let's see why from a user's point of view. Of course, they are machine learning and Kaggle champions we have. Andrew Ng said, coming up with features is difficult, time consuming, and requires expert knowledge. Applied machine learning is basically feature engineering. Pedro Dominguez says, some machine learning projects succeed and some fail. What makes the difference? Easily, the most important factor is the features used. Xavier Cunard says, the algorithm we used are very standard for Kagglers. We spent most of our efforts in feature engineering. Auto AI is a variation of Auto ML. It extends the automation of model building to the entire life cycle. Like AutoML, AutoAI applies intelligent automation to the steps of building predictive machine learning models. Here is a quick look into a similar process that AutoAI executes behind the scenes. There is a combination of data preparation, where we find the best pre-processing, imputation, encoding, and scaling strategies. You have model selections, where we find the top K estimators. We have HPO, which is a hyperparameter optimization on selected estimator. Feature engineering, which finds the best data transformation sequence. A second round of HPO on estimator after feature engineering. And last, ensembling, where it computes ensemble predictions based on pipeline predictions. So let's cover more in Auto AI terminologies. The first is machine learning pipeline. It's a set of steps for creating a model or workflow. Typical steps in a pipeline are ingest, clean, transform, and model with hyperparameter optimization. We talked about estimators in a slide before. It's basically referring to algorithms. For example, we have logistic regression, random forest, etc. HPO, hyperparameter optimization, is the process of training the models with different parameters specific to each algorithm. It's just like how you play with your computer settings to get something you need, to get the desired outcome. How do you tune the parameters of a model to get the optimization, right? So that is hyperparameter optimization, in a very quick explanation. We then have model evaluation metrics, the various model evaluation metrics used by data scientists, AUC, ROC, F1 score, etc. So these four are the major Auto AI terminologies. And next, I would like to show you some screenshots here where we have the Auto AI kind of being set up. One of the major steps that you need to do is, since it supports the CSV file, we just need to drag a CSV file into the experiment page and then select the column that you want to predict. Once the column is predicted, it would analyze and understand what is the prediction type, what is a positive class, and the optimized metric. And as users, we can select the different automated machine learning parameters ourselves as well, right? And then you just have to click on Run Experiment, and there you go. A pipeline leaderboard is generated, and you can also see a star against the the best performing model. It shows the pipeline information as well. Next, we can also deep dive into the model evaluation part. It will review the accuracy for you, the precision and recall to assess the models better. And in a click of a button, you could actually deploy. How? We promote the models to deployment spaces. You save the model of your choice, and a click away is a deploy. This was just a quick demo of what we have in Auto AI. All these steps that we've covered are inbuilt, and all you need to do is just drag and drop a CSV file, select the column that you want to predict. It would suggest the optimized machine learning parameters. You have the option to change as well. This is one tool. There are similar tools that are used across the industry to make life of a data scientist much better, and it saves loads of time. So just to summarize what we've seen, it can help build your models faster. It can jump the skills gap. It can discover more use cases because you get to analyze your data better. It can also find the signal from noise, rank and explore models, and gets you ready, set, and deploy in few clicks. So thank you all and a very happy learning to all of you. Thanks a lot.